Hello friends, let me talk on ridge regression today. So it's a method of regression that we use when the independent variables are highly correlated, when there is high collinearity among the independent variables. So it is used in econometrics, chemistry, engineering. So ridge regression allows improvement in efficiency at the cost of a tolerable amount of bias. Since we put some restriction on the parameter space, it fails to be biased, but it has got sufficient improvement in efficiency in exchange. So a bit of history. The theory was first introduced by Horrell and Kennard in 1970 in the Technometric papers, ridge regression bias estimation of non-orthogonal problems, and ridge regression's applications in non-orthogonal problems. This is a result of 10 years of research into ridge analysis. So let us start with the linear regression. We have the independent variables, columns forming the attributes forming the columns of the matrix X. We have the unknown parameter beta and we have the target variable y. So in linear regression, we model the problem as y equal to x beta plus epsilon, where epsilon is the standard error with zero mean. So we minimize the Euclidean distance, Euclidean error. We minimize the cost function, minimize over beta, y minus x beta transpose y minus x beta, the usual Euclidean error function. And the normal equation comes out to be x transpose x beta equal to x transpose y in case of linear regression. So the estimate we multiply both sides by x transpose x inverse if it is non-singular, and we get the estimate beta hat as x transpose x inverse x transpose y, which is clear from the normal equation. And then the obvious predictor of y is y hat equal to x beta hat, predictor or regressor. We get the regressed values of y as x beta hat. So this is the linear regression scenario. In ridge regression, our model remains same, y equal to x beta plus epsilon, but we put in an extra constant on the parameter space. Beta transpose beta equal to C. I'm not very clear about the reason of this type of restriction. I need to study more, but this is the standard restriction on the parameter space in case of ridge regression. So we minimize the cost. The cost function comes out to be, we minimize over beta y minus x beta transpose y minus x beta plus lambda times beta transpose b minus c. So here comes the restriction part, and lambda is known as the Lagrange multiplier. We said before we set the value of lambda before we proceed for regression. It's a design parameter. When lambda is 0, the problem boils down to linear regression. And we get estimate of beta hat equal to x transpose x plus lambda I inverse x transpose y. And the predictor is y hat equal to x beta hat. So this is the modeling and analysis and structure of ridge regression. It helps us in improving the efficiency of regression, but the bias, it fails to be unbiased. Here is a bit about the value lambda, which is known as Lagrange multiplier. Lambda is the Lagrange multiplier of the constraint. Typically, lambda is chosen according to a heuristic criteria, so that the constant will not be satisfied. So that the constraint will not be satisfied exactly. I'm not clear about it, but lambda is to be given a heuristic value at the start of the at the design phase. And when lambda equals 0, it boils down to linear regression. Thank you.